So I want to work a little bit with you guys on writing linear equations notes. I know that a few of you have been looking at this and have had quite a few questions. So I thought maybe going through these together would help you guys out. So in looking at our box at the top, we have three special equations that carry on throughout this chapter. The first is the slope equation. M for slope is equal to rise over run, which we also know by the equation y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We have our slope-intercept form. Slope-intercept form is when we put the equation in y equals mx plus b form, where m is the slope, b is the y-intercept, and basically what that means is it's where the graph actually crosses the y-axis. Okay, then we also have point slope form. Again, m is the slope. We use the same variables to save confusion. And h, positive k, is the starting point. Now, you will notice that in our equation, we have m times x minus h plus k. That means that because this is a minus h, we always have to reverse the value of the h to get that starting point, but k stays the same. What we actually say is the h misbehaves while the k behaves. And this is something that will carry on throughout this year as we do transformations. It's kind of an important thing here in Algebra 2. So this will be coming back. We will see it after this chapter. Okay, so looking at this first example, it says for each equation, write the linear equation in slope-intercept form. Okay, so I'm looking at the first one, and I'm going to depend on rise over run to do my slope for this. So if I start at this point, 3, negative 1, and I count up to 0, 1, I'm counting up 2 units, and across to the left, 3. Okay, so my slope has a rise of positive 2, but notice how I'm moving to the left. That's a negative direction, so that's going to be negative 3. We can also confirm this by noticing that as we move from left to right, our graph is sloping downhill. Okay, the next thing I need is the y-intercept, the b. And so the b is at the point 0, 1. So I'm going to have b equals 1. Now all I have to do is plug into the equation. So it's going to be y equals negative 2/3 x plus 1. All right, let's look at b. Okay, in example b, we have the equation, or the graph here. Again, I'm going to count my rise over run. So I'm going up 1, which is positive, 2 to the right, which is also positive. So m is equal to 1 over 2. The y-intercept b is equal to 1, because it crosses the y-axis at 1. And so the equation is y equals 1/2 x plus 1. All right, so that is our slope-intercept form. Now let's look at point scope. All right, so again, I need my scope. So I'm going to count up a rise of 1, positive, and across, positive 2. So this has a slope equal to 1/2. Rise 1, run 2. Okay, now the next thing I need is a point that the line goes through. And I'm going to use this one right here. I could use this point. I could use this point. It does not matter. But in this case, for point scope, I'm going to use 2, -3 as my point, and it's right there on the line. Okay, so I'm going through the point 2, -3, and my equation is fill in the blank. Again, it's the equation that we have up above, y equals m times x minus h plus k. So all I have to do is fill in the variables. Y equals 1/2 of x minus 2 minus 3. Okay, on D, again, we've got our slope that we need to get first. And in this case, we're going up 3, which is positive, 2 to the left, negative. So, -3 over 2. Again, going up is positive, but going left, 2 is negative. So that gives us our -3/2. We also have a point at -2, +1. That I'm going to use as my starting point. I could have chosen one of the other points that's on the graph, and that would have been perfectly fine. But I'm choosing at this point -2, 1. Okay, so to write the equation, it's going to be y equals -3 over 2 times x minus h, so minus -2 minus a negative would be plus 2, plus k, which is 1. Okay, now one thing that we should take note of is that because there are multiple points that we could choose on the graph, that we will not necessarily have the same equation. What you choose as your point may be different from the person sitting next to you. And so because of that, there are multiple answers that could be correct. All right, the next thing that we're asked to do is graph the equation based on the information below. So this is actually working in reverse. I know that I have a slope equal to -3/4. I also know that my y-intercept is at +2. So for the graph of this, I am going to go up on the y-axis 2 units. My rise over run is 1, 2, 3 rise, 1, 2, 3, 4 run. Okay? So that gives me my equation. Okay, so again, y-intercept was 2, and since I had a slope of -3/4, I count up 1, 2, 3, but I need to have the -4, so I'm going 1, 2, 3, 4 to the left. Our next example, we are graphing in point slope form, and you know what? They did something kind of interesting here. They subtracted 1 from the y. Now, to put it in the form we're used to seeing, I need to add 1 to both sides. So y is now equal to 1/3 x plus 2 plus 1. That means that the slope is equal to 1/3, and that my starting point is going to be at the opposite of positive 2, negative 2, positive 1. So I'm going to go to negative 2, positive 1 as my starting point. And then my slope is 1/3, so I'm counting up 1, 3 to the right. Up 1, 3 to the right. If I go down 1, I'm going 3 to the left. And so, there is our line. Okay. So again, this equation was y equals 1/3 x plus 2 plus 1. My slope is 1/3. My starting point is at negative 2, 1. So I'm going to negative 2, positive 1, counting a slope of 1/3, so up 1, 3 to the right, up 1, 3 to the right.